Hello, everyone. Today we are going to talk about sequences. So what is a sequence? Well, there are many different definitions of a sequence. Normally, it's ordered set of numbers. We are going to give a next definition. Sorry. Let me erase this. Somehow my marker is still yellow. So a sequence is a function whose domain is the set of positive integers. Well, for example, let's consider f of x equals x squared. Before, we were allowing x to be any real number. Any real number means that it can be 1, 2, 3, or -1, -2, -3, or it can be fractions like 5/7, or it can be rational numbers like square root of 2, or even can be transcendental numbers like e or pi. For sequences, we're going to assume that x can take only values 1, 2, 3, 4, and so on. So, well, for example, here for x equals 1, the value is going to be 1 squared, right? And then next value is 2 squared, and next value is 3 squared, and so on. There are infinitely many values here because the set of natural numbers is infinite, and that's called a sequence. So terms are called elements, right? Sometimes they're called terms, sometimes elements. What else? We are going to label them as A1. So A1 is equal to 1 squared, or just 1, right? A2 equals to 2 squared, or 4, and so on. AN equals to what? N squared. Here, index is showing the position of the element in this line. And you see that element itself depends on this position like n squared. Okay? Well, what other ways we can use to determine a sequence? Well, there are several different ways. Way number one, we can set up a sequence as a formula. Like an equals n over n squared plus 1. How this sequence is going to look? This is element n, or term n. A sequence is going to look like this. You plug in 1 here. So a1 is going to be 1 over 1 squared plus 1. So it's 1 over 2, right? The first element is 1 over 2, and then a2, 2 over 2 squared plus 1. It's 2. 2 squared is 4. It's 2 over 5. 2 over 5. Let's calculate one more. A3 is going to be 3. 3 squared plus 1. So it's going to be 3 over 10. And you can continue this. So sometimes it's not very convenient to write down the numbers or all terms of the sequence, but it's easier to give a formula for term number n, which can be generally used if you substitute to find the kind of term with position 3. We're going to plug in 3 into this formula, 3 here, over here in the index, and 3 over here into a formula. Well, another example of a sequence, number 2. I'm going to give it as a set of numbers. It's 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16, and so on. So I don't give a general formula here. Well, it's kind of easy to find out the general formula here if we look how we move from term to term, right? You see that to move from 1 to 1 over 2, we kind of take this term and multiply by 1 over 2. And to move from this term, we multiply 1 over 2 by 1 more 1 over 2. Well, if you want to know term number, I don't know, 1, 2, 3, 4, 5, term number 5, A5, it's actually what? It's actually 1, the first term, by 1 over 2, term 2 by 1 over 2, term 3 by 1 over 2, term 4. So, and by 1 over 2, term 5. Oh, yeah. So I'm kind of counting the jumps. So 1, 2, 3, 4, 4 jumps. We are doing 4 jumps. So this is term number 2. This is term number 3. That's term number 4. And the last one is term number 5, right? If you want to write down the formula here, the formula is 1 over 2 to the power of n minus 1. Complicated formula. Why? Because number of 2's here is 1 unit less than position of the term. Okay. What other sequences we can have? Well, sequence can have alternating sign. Let me give you a sequence which goes nowhere. It looks like 1, minus 1, 1, minus 1, 1, minus 1. Is it a good sequence? Yeah, that's a sequence. Sequence of alternating ones and minus ones. How do we give a formula for this one? Let me kind of teach you how to get a formula for this one. So term an equals minus 1 to the power of n plus 1. Let's see what I'm doing. You know that minus 1 to even powers is going to give you 1, like 1 minus 1 squared or minus 1 cubed. I'm going to write out minus 1 squared is 1, right? Minus 1 to the power of 4 is 1, but minus 1 to the power of 3 is minus 1, or minus 1 to the power of 5 is still minus 1, because we have odd amount of minuses and not all of them are canceling, right? So basically we can get alternation of pluses and minuses manipulating with the power. Now, how the power is going to be connected to position? We see that the term a1 is going to have a positive power. If we just put over here n without plus 1, we are going to get minus 1 to the power of n, and in our case it's 1. That's going to give us minus 1 to the power of 1, which is minus 1. But we want positive power, so we're going to add 1 over here and get 1 plus 1 is 2. Minus 1 to the power of 2 is 1. But when n is 2 for this term, I'm going to write down a2 is going to be what? Minus 1 to the power of 2 plus 1, which is going to be minus 1 to the power of 3 or minus 1. That's exactly what we have, you see? Okay, now guys, I'm going to give you a factorial sequence. Just first, what is factorial? Factorial is a number n factorial, which is produced by multiplication all numbers starting n and ending 1. So it's n minus 1, n minus 2, and until you have 1 over here. I'm going to write down a few factorials so you will kind of find out like how it works. For example, 2 factorial, it's 2 multiplied by 1, very short one, right? Or 5 factorial, it's 5 multiplied by 4, by 3, by 2, and by 1. Also, there is a kind of way to manipulate with factorial. You know that this one is actually what? 4 factorial, because it's all numbers from 4 to 1 multiplied. So you can write down 5 by 4 factorial. Interesting, right? Another interesting thing about factorial, by definition, 0 factorial is not 0, but 1. We'll just remember this. Also, 1 factorial, because it's a product of all numbers from 1 to 1, is also 1. That's a little bit like strange, but accept it for right now. Okay, besides giving formulas for the sequence explicitly, we can give something which we call a recursive formula. I'm going to start with giving you a sequence. Which is which has famous name, Fibonacci sequence. Sorry, not 2b, but 2n. Fibonacci sequence looks like this: 1, 1, 2, 3, 5, 8, and more numbers. So how do we produce numbers in this sequence? Well, they definitely don't look like powers or squares of anything, right? Actually, how do we produce the numbers? We're going to add these two numbers, 1 plus 1, and put it here. And then add these two numbers, 1 plus 2, and put it here and get 3. And then add 2 plus 3, and this result put over here. So this is called recursive sequence because we are going to create a formula for it. The formula is going to be next. A That's A3, right? This is element A3. A3 equals A1 plus A2. A4 is this, sorry. A4 is this element. A4 equals what? A3 plus A2. A2 plus A3. So every next element is made out of two previous elements. I'm going to write down general formula. AN equals AN minus 2 plus AN minus 1, the previous element and the previous before previous element. Okay, so can we predict next element over here? What's going to be next element? Next element here is going to be the sum of 5 and 8, and that's going to be what? 5 plus 8 is 13. Famous sequence, Fibonacci sequence is given as a recursive formula. So to find next element, you will need to find all previous elements. Okay, now guys, what is important? While we are working with sequences, it's important to understand how summation notation works, because for sequences, we are going to find, for example, a sum of sequence. And sometimes it's kind of long to write down all the numbers, and we are going to use summation notation. How summation notation is working. Imagine that you have a sum of 100 terms of a sequence. A1 plus A2 plus A3 plus here A100. Of course, it's going to be too boring to write down all 100 terms. So what we can do, we are going to put letter S. This is Greek letter S, capital, also known as sigma. We are going to label that we are planning to start at n equals 1. My first element is 1, and end at n equals 100, and have the sum of all elements. So actually, this sigma means only one thing, that's plus. So we are adding elements, starting with element 1, ending with element 100, and sigma stays for addition. You'll probably ask me, what else can we do with element? Well, we can multiply them, and the product is going to use letter pi, a capital letter pi. I'm going to show you a couple of examples of use of sigma notation. Okay, example number 1: sigma from n equals 1 to 10 of 1 over n. What is it? It's 1 over 1, the first term, we plug in 1, right? Plus 1 over 2, we plug 2 instead of n here. 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 9, and 1 over 10. So instead of writing down these 10 terms, you can just write down 1 over n and goes from 1 to 10. Is it necessary to start sigma with n equals 1? No, you can start with n equals 2 or n equals 5. Let's try to write down next one. See what are the elements. I'm going to start with n equals 2 to n equals 5 of n factorial. So what I'm going to have n factorial, and instead of n, I'm going to plug in 2 first, and then 3, and then 5. And 5 is going to be my last element because 5 sits over here. Well, you can calculate what is going to be the number. Right now, it's not super important. Well, another example of sigma notation is sigma from k equals 3 to k equals 7 of k squared. Again, letter over here in the sigma, it's not important how you call it. Usually people are using like letters N, M, L, K, but you can also call it X actually. You just understand that this axis can be only natural numbers. So we're going to have 3 squared plus 4 squared plus 5 squared plus 6 squared and plus 7 squared. So last number is 7 and the first number is 3. Okay. What are properties of sigma notation? Properties, very, very briefly, just a few properties. Well, property number 1. What is sigma n equals 1 2, for example, 5 of ones. Number does not change with changing positions. It's 1. It's 1 plus 1 plus 1 plus 1. 5 times 1, right? It's going to be just 5. Or 5 times 1. So the rule is going to be next. If you have n equals 1, choose some number, I don't know, m of ones, that's going to be 1 m ones. Let me write down m first. M ones. So there are m in this sequence. Okay. Next property. Imagine that you have a sigma of a constant multiplied by term n, and let's say from 1 to, I don't know, 10, for example. What is going to be? It's going to be constant by a1 plus constant, the same constant by a2, and plus 10 other terms, a constant by a10. Because constant is same everywhere, you can take it outside of your parentheses. So it's a1 plus a2, a10, which is going to be equal to constant and then sigma of an, and from 1 to 10. You see that sigma can be taken out, and not sigma, constant can be taken outside of a sigma if it's the same constant for all terms. Okay, and the last property, property number 3. If you have a sigma and there are two terms, an plus bn under 1 sigma, and then let's go from 1 to 10. How it's going to look? a1 plus b1, right? Plus a2 plus b2 plus term number 10 is going to be a10 plus b10. Now, guys, we can write down a separately and b separately, right? a1 plus a2 plus a10 plus b1 plus b2 plus b10. And then this one is going to be what? Sigma of an, and from 1 to 10. And this one is going to be sigma of bn, n from 1 to 10. For us, guys, it's going to look like we can distribute the sigma into parentheses here and over here, kind of distributive law. If you have a minus here, it's going to be minus everywhere, here, here, and here, and all b's are going to have a minus, which is going to result into a minus over here. So plus or minus does not matter. Okay. Okay, what else do we need to know about sequences? Well, let's try to kind of just work a little bit with these properties. Basically, that's not much to explain more. For example, guys, some problems to solve. Problem A, I want you to find out what is going to be the sequence 1 to 10 of 2. So you have 2 plus 2 plus 2. And last one is 2. How many 2's we have? We have 10 2's, right? Starts with 1, ends with 10. It's going to be 2 multiplied by 10. What else? Well, we are going to get some other formulas, like for a sum of a sequence, a little bit later, I think, when I'm going to teach you arithmetic sequence. So for right now, maybe another problem is going to be, can you find a term number 5 of a sequence with a1 equals 1 and a2 equals 2, and recursive formula an equals an minus 1 by an minus 2. So I'm asking, what is a5? Kind of self-problem. Can you stop the video and try to find out using this formula terms, remaining terms until term 5? Okay. And I'm going to count to 5 and kind of continue solve it myself. So 1, 2, 3, 4, 5. So according to my formula, A3 is A2 by A1, right? In our case, it's 2 by 1. A4 is A3. Sorry, I'm going to write it and write it. It's A3 by A2. If this is 4, then this 4 minus 1 is 3, and 4 minus 2 is 2. 3 is equal to by 3 is equal to by 1, and 2 is equal to just 2, right? That's my A4, and A5 is going to be A4 by A3, which is going to be 2 by 1 by 2. I'm copying this one over here. It's A4, right? And A3 is 2 by 1. Now, guys, I'm just going to multiply everything and get the final answer. So I have 1, 2, 3 2's, right? It's 8, right? Multiplied by 1 and by 1, it's just 8. And other terms, this one is 4 and this one is 2. So if I write down the terms of this sequence is 1, 2, 2, 4, 8, and so on, if I write down them. Okay, that's all about sequences. Just try to do the homework, work a little bit with sigma notation, okay? And I'll see you next lecture.